use in the classroom that attach to each other and can construct these diagrams and models that I'm going to be building with technology. So we're going to start with a yellow unit cube. That means the dimensions are 1 unit by 1 unit by 1 unit. Think of the unit as an inch or a centimeter. So the volume of this yellow cube is length times width times height, or 1 times 1 times 1. So we're starting with a volume of 1, and we want our students to develop an understanding that just as area measures the number of square units in a region in 2 dimensions, volume measures the number of cubic units, and here's our first one. So we're going to add on, and the question we're going to be asking is, how many of these unit cubes do we have to add on to get the next larger cube? Or what is the minimum number, the least you have to add on? We could do this using mathematical formulas. We could bring algebra into this later on, but we could also physically construct it using software like this or manipulatives. So let's physically do this. We're going to take this cube and let's add another cube. Well, let's change the color first to blue, and let's attach a second cube. Now we have made what is called a rectangular prism or rectangular solid. Of course, it's a box. What is its volume? Well, we know it's made up of 2 unit cubes. So counting cubes, we see the volume is 2 units cubed, or 2 unit cubes, or 2 cubic units. Different ways of expressing that idea. We could also use the formula for volume. The length, say, is 2, the width is 1, and the height is 1. 2 times 1 times 1. But we haven't made the next larger cube. So we're going to have to add on to that. So let's put one here. Okay, and we're going to move this over a little bit and rotate it. Can you see where I'm going to place the next cube? I think so. So we'll go back and we're going to add another cube right there. So now we have completed an object. It's a box, rectangular solid, rectangular prism. Its volume is 4, the 1 yellow plus the 3 blue unit cubes, 2 by 2 by 1, but it is not a cube because its height is not equal to the length and the width, so we're going to have to add a second layer. But I also want you and students to recognize that we can look at this diagram from the top down. And when we do that, we're looking at a square face, 2 by 2, whose area is 4, and there are 4 unit squares. So there is a direct parallel between adding more cubes to our solid or adding more squares to one of its faces. And we'll keep going back and forth on this. I'm going to go back to the other view, and let's add a second layer. So we'll change to a different color, and we're going to add there, 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 and there. And let's take a look and see if we have in fact completed our next cube. So we have our 4 cubes on the bottom, and now we have our 4 cubes on the top. The dimensions of this solid are now 2 by 2 by 2. What is its volume? Either we count cubes, 4 on the bottom and 4 on the top, and we can add the necessary lines for that purpose. Or we can just get the volume by multiplying length times width times height. 2 times 2 times the height of 2, which is 8, or 2 to the 3rd power. What about making the next larger cube? To get from the smallest cube, our unit cube, to this one, what did we add on? We added 3 to the bottom layer and 4 to the top, so we've added 7 unit cubes for a total of 8. What will we have to add on this time? All right, so let's start building. And probably going to use another color. And we'll change it to, let's say green. So we're going to add on a green here. And here, notice I'm working on the bottom layer. There. And there. Well, let's turn this actually, because I want to stay with the bottom layer. All right, and let's turn this around. So what have we got? Well, if we're looking at the bottom face, how many squares did we add? From the yellow, we added 3 blue squares to complete that square. Sounds like an algebra statement, right, folks? And we added that odd number, 1 plus 3, and we get that next square, 4, which is 2 by 2. Now we're adding on the green, and you can see there are 5 additional squares. 2, 2, and 1. The 2 green squares bordering on one blue side, another 2 squares bordering on another blue side, and then the additional 1 in the upper right-hand corner. So we have 5 more squares. So what do we have right now? We know there are 9 squares in this face, 3 times 3. But we also see it as 1 yellow plus 3 blues plus 5 greens for a total of 9. But we have to add on to complete the cube. So let's do that. So we're going to add more greens. Okay, let's do that. Okay, so we have, and let's turn this. And now we're going to complete the second layer. Let's take a look at our diagram. What do we have? We have a nice rectangular prism. Its dimensions are 3 by 3, but 2 high. That's the number 2, not TOO. Ha ha ha. And it's not a cube. So what do we need? Well, what have we added so far to the 2 by 2 by 2 cube? We added 5 green cubes on the bottom layer, and we added 5 green cubes on the next layers for a total of 10. Can you predict how many more we will need to finish our cube, to complete our cube? All right, let's find out. So we're going to start adding on, and we're going to go to violet, and we have, let's take that off. We work from the back. And there we have it. Rubik's Cube yet? So how many purple cubes did we just add? Well, just as we can look at the 2-dimensional face and see 9 squares, there are 9 cubes. 3 times 3. 3 rows of 3. So what have we added to the 2 by 2 by 2 cube? We added 2 layers of green, 5 each, right? 5 plus 5 is 10. And how many purple cubes? 9 more for a total of 19. Let's see if that makes sense from our formulas mathematically. We know the volume of this 3 by 3 by 3 cube is 3 times 3 times 3, or 27, or 3 to the 3rd power. Our 2 by 2 by 2 cube, remember what that one was? That had a volume of 8. To get from 8 to 27, we have to add 19, and that verifies the count. Can you predict how many more cubes will be needed to build the next larger cube, 4 by 4 by 4? Yes, you can use the volume formula, but can you visualize it? Thank you.